In this video, I'm going to talk to you about putting all the factoring strategies together and being real and understanding how to factor no matter what kind of problem you're given. The first thing I should say is that if you don't know how to do one of these strategies, you should watch the other videos. And so let's begin. When we factor, there's always the possibility that a number can't be factored. For example, if we tried to do a factor tree for the number 7, the only thing we'd come up with are 7 times 1. That means that we have a special name for 7, since it can't be factored other than putting 7 times 1 in front of it. We call 7 a prime number. Well, just like we have prime numbers, we have prime polynomials. So x plus 2 is a prime polynomial. We can't factor it anymore. 2x plus 2 isn't prime because it can be factored. It can be factored by using the greatest common factor. The greatest common factor of these two terms is 2, so when I factor out the 2, I now have 2 times x plus 1. Notice that each of my factors now is a prime polynomial. And I intend this to be, both of these are prime polynomials. So x plus 1 is a prime polynomial, and 2 is a prime polynomial. For the purpose of this video, when I say a polynomial is prime, the way that I'm going to decide if a polynomial is prime is if it can't be factored using the strategies that we've learned so far. Let me give you a process for factoring this expression, 6x cubed plus 32x squared plus 10x. The process I'm going to try and give you should work for any expression that you need to factor. I'm going to start by trying to factor out a greatest common factor. So when I look at this expression, I can tell that 2 goes into all these numbers because they're all even, and there's an x that could be a factor of each of the terms because there's an x in each term. So I'm going to factor out 2x to begin with. That leaves me with 3x squared plus 16x plus 5. Okay. So I always start by looking for a greatest common factor. Now that I've taken out the greatest common factor, I need to try and factor all the factors that I have left. Well, 2x can't be factored any further. But can I still factor 3x squared plus 16x plus 5? Well, to figure that out, I have to look back up at my factoring strategies. And since 3x squared means that I have a coefficient of x squared, I'm going to try and split the middle. So I'm going to multiply 3x squared times 5, which gives me 15x squared. And I'm looking for numbers that multiply to 15 and add to 16. So I have 1 and 15, 3 and 5, and they have to add to 16. So 1 and 15. So now I'm going to work on factoring this term, 3x squared plus 16x plus 5. And I'm just going to imagine for right now that I don't see the 2x or these parentheses. I'll bring them back in a second. Right now I'm just working on this part of the expression. So I'm going to split the middle. That gives me 3x squared plus x, because that's 1x, plus 15x plus 5. Now I'll group them. The greatest common factor here is x, and that leaves me with 3x plus 1. And the greatest common factor here is positive 5, so plus 5, 3x plus 1. So I get 3x plus 1 times x plus 5. And remember that I had left off the parentheses and the 2x. Well, really, what I was doing this whole time was just inside the parentheses here. And I wasn't changing anything outside them. So now when I've factored it, I could put parentheses here and write the 2x outside a larger group of parentheses. But that'd be kind of like writing this, 2 times 3 times 5. It doesn't matter if I multiply these two first and then the 2x, or if I multiply just 2 times 3 times 5. It's called the associative property. That means that I don't really need these parentheses to begin with. So I'm going to write my answer as 2x times 3x plus 1 times x plus 5. Again, notice, in this expression, when I finished factoring it, I ended up with 3 factors. 2x, 3x plus 1, and x plus 5. Each of these factors is prime. I can't factor them any further. There's no greatest common factor there for me to factor out. And so this expression has been completely factored when it's written like this.